Hi everyone. Today we are going to study about system calls. What are system calls and what are they used for? System calls provide an interface to the services made available by an operating system. We know that operating system provides certain services. So system calls provide an interface to these services. Before we try to understand system calls in more detailed way, there are two important points that we need to know, which is the two modes of operations in which a program can execute, which are known as user mode and kernel mode. User mode and kernel mode are two modes in which a program can execute. So, if a program is executing in user mode, then that program doesn't have direct access to the system resources like memory, hardware, etc. But if a program is executing in a kernel mode, then program has direct access to the memory, hardware and such resources. So if we say that if a program is running in kernel mode, then it is in privileged mode because that program has all the privileges to access all the system resources. But the problem is that if a program is running in kernel mode and if it happens to crash, then the entire system will crash. But if the program is running in user mode and if it happens to crash, the entire system does not crash. So the user mode is safe mode. Okay, so we call that user mode as a safer mode, though kernel mode is the privileged mode. Since the user mode is a safe mode, most of the program will execute in the user mode. But while execution, it may need to access the system resources, okay, like memory, hardware, etc. Okay, so when program needs access to these resources, it makes a call to the operating system telling that I need an access to certain resources. Okay, so when it makes that call, program switches from user mode to kernel mode, and this is called context switching. And the call that the program makes in order to access those resources or to go on into the kernel mode, that call is known as system call. So what is the main purpose of the system call? System call is the call to the operating system saying that the program needs access to the certain resources, and this call is calling as the system call. It makes the program to change from user mode to kernel mode, and that process is calling as context switching. The context switching is nothing but the program switches from user mode to kernel mode. Okay, so these system calls are available as a routines written in C language. That means how we are writing functions in the C language, in the same way we have written the system calls. Okay, so the way that a program talks to the operating system is via system call. Then the next point, it is very difficult and time consuming to implement the system calls since it requires saving the program or states. That means when we are executing the kernel system calls, we need to store the states. So in order to store that states, we need to use stacks, registers and so on. That's why we are saying system call implementation is a difficult and time consuming task. Okay, then as I mentioned earlier, while executing the system calls, we need to change from the user execution mode to kernel mode. That is the system call. In simpler word, it is the interface to the services available by the operating system. Okay, We have four types of system calls: file related system calls, process related system calls, interprocess communication related system calls, and system calls for handling signals. And these four type system calls we are going to study in detail in today's video. First, we will see the file related system calls. So what is file related system calls? System calls which are used to perform operations on files such as creation of a file, opening of an existing file, reading, writing, closing, etc. Okay, so if we have a file and if we want to do certain operations on the files, what all system calls we are using for those purposes we are called as file related system calls. Now we are going to see the file related system calls. So the first one is the create system call. First one is the create system call. As the name indicate, the create system call is using to create a file. Now we'll see what is the syntax of create system call. And the syntax is file descriptor equal to create, and we have two arguments, name and permissions. That means name indicate we are going to create a file with this particular name, and permissions means what? When we create the file, what all permissions we have to assign, like read, write, execute. Okay, it will be representing with a 4-digit number, and always we know that file access permissions will be a 3-digit number, and here when we are specifying the permission, it has to be preceded with 0 and followed by the 3-digit number. Each digit is indicating the permissions of each type of users. So the first letter 6 is indicating what all permissions user has. Second letter is indicating, that is the third letter 6 is indicating what all permissions group members has. Then last 6 is indicating what all permissions others has. So 6 means it is the combination of 4 plus 2. 4 means the value of read, 2 means write, which means all the users, that is user has read and write but no execution permission. Group members has read and write, that is 4 plus 2 but no execution permission. Again others has read and write but no execution permission. So this is the syntax. Once we created the file, it will return a unique integer that is representing, that is identifying an open file. That value will be assigned to the file descriptor. So file descriptor is a number that uniquely identifies an open file in the system. Okay, so after creating, the integer uniquely identifying that particular file will be stored into the file descriptor. Okay, so if we were able to successfully create the file, then it will return the file descriptor. Otherwise, if you are not able to create the file, what the return value will be -1. So this is the first system call, create system call, to create the file. And we have seen the syntax. Now we are moving on to the next file related system call, that is open system call. Open system call means what? As the name indicate, it is using to open an existing file. Now let's see the syntax of the open system call. File descriptor equal to open with 2 arguments, file name comma mode. Okay, so file name argument indicates that with the name of the file which we are going to open, and mode means what? Mode specifies the purpose of opening the specified file, that is like whether it is opening for reading or writing, etc. That is mode. Mode specifies the purpose of opening the specified file. Once we have opened that file, we will return the file descriptor. Again I am repeating, file descriptor is a number that uniquely identifies an open file. Okay, now in the place of mode, it accepts 3 values. Okay, so if we are giving mode value as a 0, which means we are going to open the file for reading purpose, And if the mode argument value is equal to 1, which means we are going to open the file for writing purpose. And if the mode argument value equal to 2, which means it is opening for both reading and writing purpose. So that is the next file related system call, open system call. It is using to open an existing file, and once it is opened, it will return the file descriptor. And we will be sending the file name and mode of the file as arguments to the system call. Then the next system call is file related system call is close system call. Again, close, as the name indicate, it is using to close a particular file. So we need the file descriptor of that file, the unique integer identifying the file, that is the file descriptor. So this is the syntax of the close system call. Close and argument, what is the argument we are passing here? File descriptor indicating a particular file. So it is used to close the already open file. Next file related system call is unlink. Unlink system call is using to delete an existing file. Okay, so we want to delete a particular file from the file system. For that we are using unlink. So the syntax is unlink and the argument passing to the system call will be the name of the file. Then the next system call is read system call. Read system call means, again, we are going to open the file to read the contents from that file. It is used to read the contents from a file. What is the syntax of the read? Read, and the arguments, what are we passing? The arguments will be file descriptor, comma, buffer, comma, n. That means we are going to read n number of bytes from the file indicating by the file descriptor, and those many bytes will be stored into the buffer. Okay, so those many bytes will be stored into the buffer. So buffer acts as the destination. I repeat, read system call will read n number of bytes from the file indicated by the file descriptor, and those many bytes will be stored into the buffer. Okay, so that is the read system call, and buffer here it has the acting as the destination. File descriptor is the your source from which file you are reading. Okay, then n, how many number of bytes you want to read from the file. Next one is the write system call. Write system call means what? We are going to write some content into the file. So it is used to perform the writing operation. So what is the syntax? Write, file descriptor, buffer, n. These are the arguments we are passing to the write system call. File descriptor, comma, buffer, comma, n, which means take n number of bytes from the buffer and write it into the file indicated by the file descriptor. Read n number of bytes from the buffer and write those many number of bytes into the file indicating by the file descriptor. Okay, that is the write system call. Now we are moving on to the last file related system call, that is lseek system call. Lseek system call means we know that there will be a file pointer in each file. Okay, so it is used to change the file pointer position to a specified location. Okay, so file pointer we are using to read write operation, right? Suppose we want to read from particular location, so we need to change the file pointer to a different position. For that purpose we are using lseek system call. It is used to change the file pointer position to a specified location. Let's see what is the syntax of lseek system call. The name of the system call is lseek and the arguments are file descriptor, offset and whence. Okay, so file descriptor means in which file we are changing the file pointer. So that file descriptor corresponding value is indicating by the first argument. Offset means what? How many number of bytes to be moved. that is indicating by offset. When we are changing the file pointer, how many number of bytes to be moved, that value is indicating by offset. Whence means what? When we are changing the file pointer, from which position we have to count those many bytes, or from what position we have to change the file pointer. Okay, so here that is indicating by whence. It accepts three values. If whence argument value is equal to 3, which means we have to change the file pointer from 0 and how many number of bytes to be moved, whatever value we are given in the offset, those many bytes to be moved from the beginning of the file. So 0, if we are giving whence value as 0, it indicates that from the starting of the file we have to move the file pointer. If I am giving whence value as 1, which means what is the current file pointer position, from there we have to move offset value. Okay, then 2 indicates what? From the end position. From the end position, how many number of bytes we want to move, those many bytes will be moved from the end position. File pointer will be moved those many number of bytes from the end position. Again I am repeating, L6 system call to change the file pointer position in a file, and 3 arguments it has: file descriptor, offset, whence. File descriptor is indicating which file, offset is tells how many number of bytes to be moved, whence indicates from which position we have to count the number of bytes. So if it is from the beginning of the file, whence value will be 0. If it is from the current position, it will be 1. If it is from the end position, it will be 2. So we have done with the first type of system call, that is file related system call. We have what all are the file related system call? Create system call to open a file, create a file, open system call to open a file, close system call to close an open file, then read system call to read contents from the file, write system call to write contents into the file, then L6 system call is used to change the file pointer position, and the last one was unlink, delete a particular file from the file system. Now we are moving on to the second category of system calls, that is process related system calls. Again, the system calls which are used to create, execute and terminate the processes. Okay, so when I have explained the process commands topic and the process management topic, I have already discussed with you these 4 types system call. Again I want to repeat this. So we have 4 types of process related system calls. Those are fork, execute, that is exec, wait and exit. We'll see one by one. So what is the first one? Fork system call. So it is used to create a new child process. So fork system call is using to create the new child process. Now let's see what is the syntax of the fork system call. Process ID equal to fork system call. After executing the fork system call, we will create a new process. What is the ID of that process will be stored into the variable process ID. Okay, so after the execution of the fork system call, it will return the process ID to the parent process, and it will return 0 to the child process, and if we were not able to create the new process, the return value of the fork system call will be -1. Okay, so the first process related system call is fork system call. It is used to create a new process, and the syntax is process ID equal to fork system call. After the creation of the new process, it will return the process ID. It will store the process ID into the variable process ID. So after the execution of the fork system call, it will return process ID to the parent process, 0 to the child process, and -1 when it is unable to create a new process. Now we are moving on to the next process related system call, that is wait. Okay, so when the parent process is calling the child process, parent process has to wait until the execution, until the termination of the child process. So that for making the so in order to make the parent process to wait until the completion of the child process, we are using the wait system call. Okay, and here we have an argument ampersand status. Okay, that means after executing the child process will return an integer. That integer will tell us what is the status of the child process execution, and ampersand is the pointer to that integer. Again I am repeating, ampersand status means it is a pointer to an integer where the Unix system stores the value returned by the child process. So status indicates it is an integer value returned by the child process. That integer value tells whether what is the status of the execution of the child process, and ampersand indicates it is the pointer to that integer value. Okay, so that is the what wait system call. Next one is the execute system call. That means this particular system call is used to execute the particular child process. Okay, then we have the last process related system call, that is exit system call. Exit means what? Terminate the process. Okay, so in order to terminate the process, we are using the exit system call. After the termination of the process, exit system call will return an integer value. If it is 0, which indicates the process has executed successfully, terminated successfully. If it is -1 means, or sorry, if it is a non-zero value, it means some error has occurred. So again I am repeating, exit system call is using to exit or terminate the process. When it is terminating, if the exit system call is returning 0, then it indicates the termination or the process has terminated successfully. If exit system call is returning non-zero value, it indicates that some error has occurred while we are executing the process. These are the 4 process related system calls. So the first one is the fork system call to create the new process, and it will return the process ID. Then second one was wait system call. It will make the parent process to wait until the termination of the child process. And ampersand status is the argument. It is a pointer, points to the integer returned by the child process. Okay, exec is using for executing the process, exit to terminate the process. Okay, now we are moving on to the next category of system calls, that is interprocess communication system calls. That means we are having different processes in the system. If one process wants to communicate with the other process, we can use these kind of system calls. And mainly we have 2 types interprocess communication system calls, that is pipe and dupe. Okay, so first we'll see what is pipe system call. We have already studied pipe operator, right? What is the purpose of pipe operator? Pipe operator is using to combine 2 or more commands. I can say in other way, 2 or more processes. Left side we will be having one process or one command. Right side we will be having another process or command. So what is the output of the left side command or process? It will be given as the input to the right side command or right side process. So it is one way of interprocess communication, right? So for that, pipe system call is used to implement the operation of the piping operator. So pipe system call, whenever we are executing the pipe system call, it open a pipe. Pipe means it is an area of main memory that is treated as a virtual file. Okay, so whenever we are executing pipe system call, actually it is opening a pipe. Pipe is nothing but it is a area in the memory that is treated as a virtual file. So whenever the processes are interacting with each other, the data will be placed in this pipe or this area of memory. So that is the pipe system call. It allows the process to interact with each other. What is the function of the pipe operator? Same way the pipe system call is used. It will open a file, that it will open a virtual file. That is nothing but it is a area of memory. It is used for the interprocess communication. Then the next system call is dupe system call. I told you whenever we open a file, there will be a file descriptor, that is the unique number indicating the file. Okay, so if we want to duplicate the file descriptor, we are using the next interprocess communication system call, that is dupe. Okay, it is for duplicating the file descriptor. So we have mainly two types interprocess communication system calls, that is pipe and dupe. Now we are moving on to the last type of system calls, that is system calls for handling signals. So what is the purpose of signals? When one or more processes are executing, if it wants to communicate with other process, or if any error has occurred, or if this process has hung up, that time it will send the signal. Okay, so signals are used to exchange information between processes. Processes can implement signals whenever there is an error, hang up, or to communicate with other processes. And mainly we have two types system calls for handling the signals, that is signal and alarm. Okay, signal means it will execute the particular signal, and alarm means for each process there will be set with an alarm. Okay, once the alarm goes off, it will send the alarm signal. Okay, and we are going to see what are the three ways of handling the signals. Whenever a signal occurs, there are three ways of handling the signal. Either we can ignore the signal, that means we are not doing with anything with that signal. Otherwise, terminate the program itself. Without handling anything, we can terminate the program itself. Otherwise, catch that and handle the signal. What is the signal indicating? That function we have to perform, catch and handle that signal. These are the three ways of handling signal. To do these, we have mainly three types of signals, that is SIGHUB, SIGINT and SIGQUIT. Okay, so these are the system calls for handling signal. Signals are using for interprocess communication, as well as whenever there is an error or hang up occurs for the process, it will indicate through the signals. Whenever a signal occurs, we can handle in three ways. Either we can ignore that signal, or we can terminate the entire program, or we can catch and handle that signal. And we have mainly two signal system calls for handling the signals, that is signal and alarm. Signal system call will do the corresponding signal function. Alarm means each process is set with an alarm. Once it goes off, it will send an alarm signal to the corresponding process. Then these are the three signals commonly using SIGHUB, SIGINT and SIGQUIT. That's all about system calls. Hope it is clear. Thank you for watching.